Are you still bored? Still stuck in the middle of a pandemic? Or still suffering a mild existential crisis? We'll help you out. Hello, fellow visitor. Thanks for joining us yet again. Hopefully, you were intrigued by our last video. Well, we'll make sure that this one is just as engaging and enlightening. For a quick recap, we left off with diagnosis in the ancient times and the Middle Ages in our last video. There, we learnt about Sushruta, Rufus of Ephesus, Hippocrates, Galen, and many other great figures which contributed for the advancements in medical diagnosis.
In this video, part 2 of a Chronicle of Diagnostics series, we'll take a glimpse at all of the historical figures in the 17th and 18th centuries and how their discoveries contributed to the field of diagnosis as we know of it today. Did the names Harvey, Malpighi, or Hewson ring a bell? Well, let's diagnose history and try to decode diagnostics, starting with these great personalities.
It was in the 13th century that people began to grind glass in order to make spectacles and magnifying glasses. Using these known techniques, you may already be aware of the fact that it was Galileo Galilei who invented the first telescope. Due to this discovery, he went on to prove that the surface of the moon is not flat. But you might be wondering, what does Galileo Galilei have to do with diagnostics? Well, it was in the year 1609 when Galileo Galilei also went on to make the first ever simple microscope by perfecting these techniques known only to spectacle makers at that time.
Around the same time, the three Dutch spectacle makers, Hans Janssen, his son Zacharias Janssen, and Hans Lippershey, are also noted for having developed the concept of the compound microscope, a tool which we routinely use in diagnostics today. Now you might be wondering why three men have been credited with the discovery of the compound microscope. Typically, it is Zacharias Janssen who is given the ultimate credit for inventing the compound microscope. Why? Well, a friend in need is a friend indeed. It is William Boreel, a Dutch diplomat, who kept detailed accounts of the letters written to him by his friend Zacharias about the device. When the physician of the French king publicly sought information regarding the origin of the compound microscope during the 1650s, it was Boreel who responded by giving information about Janssen.
Though the widely acclaimed credit of discovering the pulmonary system goes to William Harvey, a genius from the UK, many scientists or physicians such as Galen, Michael Servetus, and Rialto Colombo had observed the functioning of the circulatory system. What Harvey did was give details about the heart, such as the capacity of the heart is 43 grams. Around 6 grams of blood circulated through the heart every time it pumped, and that the heart beats 1,000 times every hour. He proved two things. First, the previously accepted theory of body consuming the blood incorrect by calculating that the heart pumps about 5 kg of blood in half an hour, and second, the existence of two separate circulation mechanisms, the pulmonary circulation and the systemic circulation. His Latin book, De Motu Cordis et Sanguinis in Animalibus, and English book, The Anatomical Exercises of Dr. William Harvey, Professor of Physic and Physician to the King's Majesty, concerning the motion of heart and blood, are quite popular amongst medical academicians.
A common instrument in every lab these days is the microscope, and the observation of microbes through it is a common practice as well. And the credit goes to, yes, you guessed it right, Robert Hooke and Antony van Luenhoek. But do we know of a Jesuit priest, Athanasius Kircher, who possibly is the first person to observe microorganisms? In one of his Latin works, there's a chapter which roughly gets translated to concerning the wonderful structure of things in nature investigated by microscope. Here, he has written, "Who would believe that vinegar and milk abound with an innumerable multitude of worms?" He has also noted that putrid material is full of innumerable creeping animalculae. This observation of his antedates Hooke's micrographia by nearly 20 years and Luenhoek's observations by a whopping 37 years.
Do you know which book is supposedly the first ever scientific bestseller? No? Okay, well, let's first see the man and the history behind this bestseller. An extremely talented master of intricate mechanical workings, contributed to the fields of architecture, astronomy, biology, chemistry, physics, surveying and mapmaking, and the design and construction of scientific instruments. Robert Hooke was a complete genius. His understanding of nature and light, his highly developed skills in designing and constructing scientific instruments, and his skills as an artist reflect in the form of a compound microscope with a new screw-operated focusing mechanism he had designed. By placing a simple water lens beside the microscope with an aim of focusing light from an oil lamp, he was successful in illuminating his specimens brightly.
He mesmerized people with the detailed diagrams of specimens he had observed from his microscope. The world Hooke had unfurled was too alien for them. His book and the first ever scientific bestseller, Micrographia, contained drawings of specimens from simple fungi to cork tree cells or plant cells to the sting of a honeybee and to the illustrations of frozen urine. His work, till date, remains immensely valuable to scientists all over the world.
Galen and his dominating theories regarding blood formation, cardiovascular and pulmonary system were widely accepted worldwide. But there was Marcello Malfigi, a genius inspired by the works of Robert Hooke, who for the first time ever disapproved Galen's theories. His revolutionary theories include thoughts about cardiovascular and respiratory system. It was written in his work De Pulmonibus Observationis Anatomicae 1661 and De Pulmonibus Epistula Altera 1661. The pulmonary capillaries connect the venous and arterial circulation. About the nervous system, he discovered the cerebral white and grey matter, tactile terminations of nerves, and the role and functioning of taste buds. He also discovered certain things about the renal system, liver and spleen function, RBCs, and gained insights about embryology. Yet, due to his conflicting theories, he had to face several physical attacks and assassination attempts as well. Once, sadly enough, he had to see his house and all of his work, including his library, get destroyed by a fire.
Another genius was Antony van Leeuwenhoek, a true scientist who had received no formal education. In spite of this, he knew no boundaries and went on to become the improbable father of microbiology. Yes, you heard that right. He devised his own unique microscopes which offered unparalleled magnification. His microscopy methods were so fine-tuned that after he discovered bacteria, this type of organism would not be observed again by any other scientist for over 100 years. He never let anyone know how he made his ingenious lenses, but we have figured it out. The smaller the lens, the greater the magnification. His microscopes were made from the smallest of lenses, a teeny 1 millimeter lens which was capable of magnifying specimens up to 200 to 300 times. With his powerful microscope, he unraveled the world of microscopic specimens. Protists, shape and size of red blood cells, bacteria, spermatozoa, and phenomena such as metamorphosis, parthenogenesis, and blood circulation.
An English physician, Sir John Floyer, was a very fortunate person, as he practiced medicine at the height of the scientific revolution and at the crossroads between the transformation from medieval Galenic approach to novel, modern-day experimental approach in science. he studied the pulse and, in collaboration with a London watchmaker, Samuel Watson, developed a watch to measure the pulse. This enabled him to become the first physician ever to study the pulse in his clinical practice. Floyer separated asthma from other pulmonary disorders and gave detailed descriptions of emphysema from a dissection which he had performed. He also advocated the concept of hydrotherapy or cold bathing.
A pioneer in exact thermometry, Fahrenheit knew his temperatures. His invention, the first practical accurate thermometer, the mercury in glass thermometer, opened new doors for primary disease diagnosis. He helped lay down the foundations for precision temperature monitoring by putting forth his world-famous and widely accepted Fahrenheit scale. The credit for discovery of the method of supercooling water, thermobarometer, and constant weight hydrometer also goes to him.
Who in the world would have thought, let's measure blood pressure by fitting a pipe into a horse's artery? Well, Reverend Stephen Hales certainly thought about this. Not only did he think about this, he also devised the first manometer or tonometer by cannulating the carotid artery in a horse with a brass pipe, which in turn was attached to a 12-inch glass tube via the trachea of a goose. With impressive originality, he decoded the contributing factors of arterial pressure, peripheral resistance, and cardiac output. Although he used this apparatus on different species for studies regarding cardiac output and systemic velocity of the blood, this setup was invasive and very discomforting to use on a human.
It was due to one of the great physicians, James Curry, that thermometry was introduced as a popular technique in diagnosis. He noted the higher and lower degrees of temperature in different patients and noted that usually human heat centered around 97 and 98 degrees Fahrenheit. He also gained practical insight on how temperature affected the living body following a nearby incident of a shipwreck in which some sailors survived and some did not. Following this incident, he was the first to use thermometry as a means of treating typhoid fever. He monitored the patient's temperature and adjusted the frequency of baths based on the temperature for successfully treating each individual typhoid patient.
So, with that, we come to the end of this journey through time. What eras the 17th and the 18th centuries were. Many of these personalities gave birth to various sub-branches in the field of medicine. With the discoveries and advancements in the field of diagnosis in 17th and the 18th centuries, the 19th century revolutionized the role of a physician in treating ailments, largely taking note of the fact that medical diagnosis was an all-important aspect of further medical treatment.
Due to these developments, the 19th century was considered to be an era of public health. Well, we're sure that you might want to know why. Then, check out our next video, part 3 of a Chronicle on Diagnostics. With that, we'll say a goodbye for now and a timely until next time. Thank you for watching!